Okay.
Maybe.
Hey, Michael. And I will mute. I'll come on if I see anything in the chat, John, that you need to see.
Okay, great. Can you see my screen okay?
Mm-hmm.
Yeah, we can.
Okay. I'm going to take the cat out so we won't keep on. Welcome to our weather discussion. We're going back to what we did in the spring under similar conditions, which is broadcasting on the BB Collaborate website. So I want to start by showing it's been quite a week. There's been fires raging for actually several weeks in the West. There was pretty heavy rain across the Midwest this week from a variety of different systems, and then there's some tropical cyclones that we need to talk about a little bit before we get to the forecast or the current weather around the country. So I want to start with some of the things that are happening out west. So here's a movie that Pete put together from satellite images over the western U.S. from yesterday, and apparently he has a new one from today, which I was not aware of at the time. So I'm showing you just yesterday. I suppose we could spend some time getting the new links to see how it looks today. But I'll just quickly do these first. And these are from yesterday. So here's the smoke pouring out of the state of Oregon, coming up all the way across California. Of course, you've seen the orange sky in San Francisco, the apocalyptic skies of what was going on out west. And it's remarkable how much smoke there is. It gives you an idea just how much vegetation's been burning over this period of time. Just incredible. So that's one really nice movie. Here's a bit of a close-up of the same time. And so you see mostly the three western states on the coast. And you can see these plumes coming out of southern Washington, most of Oregon. I think now 10% of the state of Oregon's been evacuated. So that's 500,000 people. And then who knows how many in California. So it's been an utter disaster for, as I say, several weeks. And we've heard nothing about it, of course, for a couple of those weeks out of Washington, D.C., because it's not good for the campaign. So here's, sorry, I have to say it. It's just true. And here's a close-up of the Pacific Northwest, which is also really interesting. You can really see some the fine tendrils of these individual fires, and then the conflagrations that are going on just to the east of the Oregon coast. Absolutely gorgeous, but devastating. So bad news. And in fact, in this one, I guess I could have pointed this out earlier in the prior ones as well. You can see the circulation associated with the cutoff disturbance that's meandered into the central United States over a period of days this week as well. So
hey, John, Michael had raised his hand. I'm not sure what he wanted to say. Also, I'm posting the links to these loops in the chat if anybody wants to pull them up locally.
Okay.
Yeah,
Michael,
hi, John.
Go.
Yeah, Michael.
I was just going to, when you went back to that satellite image you had up earlier that just showed over the Pacific, just to emphasize people, broad area that's kind of that brownish color, those aren't clouds. That's smoke that's all the way out in the Pacific, well to the west of the coast, all that area. And so that's just absolutely amazing in terms of the scope of that.
Right, and let's get an idea of how much space that is, because here's the width of the state of Oregon, which is some several hundred miles wide. And so here's one more length of Oregon, here's another one, and another maybe half. So 2.5 lengths of Oregon. If you were off the coast that far, you'd be able to see in the sky, in this clear sky patch especially, the smoke. That's unbelievable, actually. That's unbelievable.
And from a climatological sense, I think we're just beginning to approach the peak of sort of Santa Ana weeks away. So this is the conditions for more fires are only going to, in a climatological sense, are only going to increase in the next few weeks.
Yeah, that's 100% accurate. It's usually middle of October where the Santa Ana is at its peak. So we're 4 weeks away from that. And, those climatological conditions are pretty robust. The building of anticyclones into the Intermountain West, big ridges on the West Coast. We'll see when we look at the review of the 300 millibar jet this week, the extraordinary north-south oriented jet over the western United States this week, which has a whole bunch of different factors that played a role in weather, both over the central United States and on the West Coast. We'll get to see that in a minute. So yeah, it's been a pretty unbelievable period of time. I think in fact, I want to go to that next and look at the movie of the 300 millibar Super Pete from this past week. So let me let it load once.
Yeah, as it's loading, John, just another comment. I saw someone, I think it was Maggie,
So
asked
this is
about.
Go ahead.
Yeah, I think Maggie had asked about possibility of smoke arriving here in Wisconsin, and I saw some imagery. I don't recall the site that shows that some of the smoke, or it could be other fires, is going to be arriving through the central part of the U.S. Into the western Great Lakes region later in the next couple of days.
Wow. And we have a really sunny week on tap, so we might see the effects of it at sunset, even if we don't notice the smoke in the sky. Although those of us who have lived here a while, there are many times when we have the big fires in southwest Canada that have given our sky an obvious gray tint. There's no doubt about it. We've seen smoke in those massive fires in the summertime. I don't remember seeing it in the fall, so this would be somewhat new if it in fact happens. I'm not able to keep track of all of the different comments that might be coming on, so don't hesitate to interrupt if you've got a question. So here's
Those
the
are
300
mostly
millibar.
me, John, just posting links to the different loops that we were showing. And then Maggie said that when the winds shift, a lot of the smoke right now is in the next couple of days is going to be smoke from Colorado.
Oh, okay, yeah.
So,
So most of the like aerosol and smoke models only get out about 3 days. So you have to kind of use your imagination a little more for longer.
Do they only stop at 3 days, Maggie, because they just assume diffusion at long length scales is so big that it doesn't matter, or is there some other reason for that?
I mean, it really depends on if you're looking more at transport or if you're trying to get more of the chemical evolution.
Oh, okay.
So
Okay.
if you're looking at like a larger scale model and looking more for global transport, you can get out a few days, or you can get longer out, but your like her smoke product only goes out a couple of days.
Okay, okay.
Yeah, one of our
Thank you.
graduates, Chris Malcolm, just posted a link in the comments to the high resolution rapid refresh that Maggie, the model Maggie was just referring to. If you're curious about that.
Okay. So here's the 300 millibar analysis. Isotachs are shaded and geopotential in black, and isotherms are in red. We don't pay much attention to them at this particular level because it's often crossing over between the troposphere and the stratosphere at this level across the domain. But the isotachs are of great interest, as is the geopotential high trough that's sitting over at this time a week ago, was sitting over an axis about along Lake Superior down to New Orleans. And so let's just watch what happens on the west periphery of this as we step forward. There's the big trough. We had a nice storm over us on Friday and Saturday last week. And here comes the really impressive jet streak by about, what is this now? This is now Monday morning. And you can see this massive ridge cresting over the Pacific Northwest. And here comes the jet diving straight southward, especially at this time, perhaps, on Monday morning, diving straight southward from northern Canada into the southwest United States. So that's really a dramatic anticyclonic flow. Jet streak, of course, is going to have some upper level convergence in this location by virtue of the wind speed change, and is going to also double down on that convergence aloft because of the being downstream of the ridge axis. So the agiostrophy is additive here. The agiostrophic convergence is additive. And once you put that big anticyclone down in the lower troposphere, you initiate the really strong offshore flow, which is characteristic of Santa Ana type fire spread, which we had this week. So this is one of the elements on the very large scale that contributes to this disaster in the western United States. And I should back up a couple times. There's also this rapidly deepening upper trough in the northwesterly flow. You can hardly see any troughiness at all on Sunday morning over British Columbia. Just a little bit of cyclonic troughiness there with that jet streak over British Columbia. If you move forward in time, of course, it starts to develop quite rapidly. There's also a very intense horizontal temperature contrast there. And by this time, when you've got this folding over almost of this ridge, you can really drive an intense development, the jet exit region. And it struck me that there's a couple of reasons for that. One, of course, is the jet exit region is characterized by upper level divergence. So the air is going to be rising in that location. The thicknesses are going to drop because the air is cooling by expansion, and so the heights fall. But in addition, this is extraordinary positive planetary vorticity advection by virtue of the configuration of the jet. It spans, 30 degrees of latitude. Planetary vorticity advection here too, and this whole downstream exit portion of the jet. Consequently, that's another factor that leads to intensification of cyclonic disturbances. So everything's working for the development of the cutoff, which is now still plaguing us. Here we are on Wednesday. It cut itself off finally from the main jet flow, but that feature is lingering, and we get to our current time, and it's still at 300 millibars. It's still off to the west. We saw that hinted in the satellite picture from yesterday that Pete made. This is going to influence our weather all the way through the weekend, mostly tomorrow, but a little bit also on Sunday. So it's very long-term consequences from that rapid ridge development, which may have had some of its roots in the tropics in the far western part of the Pacific Basin. But that might get to be a little too long a discussion to have. Let's look at 500 millibars in the loop as well. And I'll just step through them. And here we are on Monday morning. Look at that intense, or Sunday morning, that intense horizontal temperature gradient. It's minus 28 at Winnipeg, and it's minus 2 at Quileute, Washington. That's almost a 30-degree horizontal temperature contrast in this region of the beginnings of this trophiness. That's a really intense upper-level front, probably more intense than it looks even in this analysis. But that's quite an intense feature on the western side of this developing upper trough, as is often the location of it. And then it rounds the base of the trough by, what day are we on? By Tuesday, and there's the cutoff at 500 millibars, which really sits over parts of the Intermountain West and had an impact, of course, on the development of some exciting weather in that part of the country as well. We'll talk about in just a minute. So lots of interesting things have happened this week, and they still have an impact on us as we sit here today and talk about the weather. Okay, so let's say something about, I've got this on my screen somewhere. Where is that? Yeah, Colorado. So Colorado had a really interesting snow event on Tuesday night into Wednesday, and Denver, they had a hot Labor Day weekend. The temperature plummeted 50 degrees in 12 hours. Let's see, they had 4.6 inches of snow at Boulder on Tuesday night into Wednesday. And there's some really interesting stats. This person who wrote this article for the Denver Times is kind of a weather geek for sure. I mean, new records of temperature drops for the month of September. Largest 2-day drop, 62 degrees. This is at Denver. Now, largest 3-day drop, 66, and that's about where it hits the wall. You go to 5 days, it's 71. They had 101 degrees for a high in Denver on, I guess it was Labor Day itself. And then by Tuesday night into Wednesday, they had temperatures in the high 30s and snow. I think there's another link here that has just an interesting little thing I want to show you. Oh, that's from the Post. I won't bother doing this. I keep getting shut out on the Post. Anyway, I think it's this one here. There's a couple of images. Yeah, 4.6 inches of snow measured at the Boulder Weather Office, and here's the picture that shows that, since we're taping things and making sure we have all the measurements. Where is it? There it is. There's a stake in the ground, 4.6 inches of snow at NWS Boulder at 9:30 on Tuesday. And then the next day it was 70 degrees. So I couldn't live there, but pretty interesting. And
still would have loved the snow, John.
Huh? I would have liked the snow, but only while it lasted. It just didn't last long enough. And that's the earliest snow I think they've seen at that magnitude in many locations in Colorado, not all of them. So this has been an exciting week. So let me show you some other things from the Midwest Climate Center. This is a really great page where you can find all kinds of measurements from the week or the hour or whatever you want. So I like the weekly and monthly maps, especially last 7 days precipitation, multi-sensor precipitation from the last 7 days. and you get the sense this is ending this morning. Now it's been updated, but here we are in central Dane County. We're in the 2 to 3 inch range. We've had that much rain over this week. It's never really rained for a prolonged period of time heavily, but it's rained quite a number of for quite a number of hours at a moderate level, I'd say for sure. And then right down in the nose of Iowa, the Dubuque area, you've had on the order of 5 to 8 inches of rain, maybe even some more. Sunday morning and Saturday night when we had the MC accumulate all this rain, I had a giant limb from my front maple tree come down, took my internet out for a few days, but it didn't do any damage to the house. We were really lucky, but it's an unbelievably large piece of wood came off this tree, and it just completely covered my front yard. So that was a little bit frightening to wake up to. In fact, we were just waking up with the windows open in the bedroom, and we heard the crash of the branch coming down. It was quite dramatic. So that's related to the front end of this whole week of prolonged rain. So that's what it's looked like over the Midwest. There have been places, I think, including Dane County, that have been unusually dry over the last several weeks, and we made up some of that ground here this week, which was nice. Okay. So let's go next to what's happening around the Atlantic Basin, which has been an interesting couple of days in the Atlantic Basin, too. We've got tropical storms Paulette and Renee out in the central part of the tropical basin. Paulette is forecasted to become a hurricane sometime over the weekend, probably by Saturday, and it looks like it's making a dead run for, here it is, it looks like it's making a run for Bermuda. So Bermuda is probably going to have a pretty serious impact from hurricane by that time, Paulette. Renee is a little bit weaker and not quite as dramatic of a threat for any land. Maybe till about a week later. I think it's a week from now, there's going to be a decent looking disturbance in the pressure fields of the forecast models. You'll see that at some point in the discussion, bearing down on maritime Canada and the far northeastern United States, but probably offshore of both, but a fairly substantial storm nonetheless. And then a couple of areas, disturbance number one with some chance of formation here off the over the Bahamas, and then another one south of New Orleans. So it could be an active week for tropical development. It may not be a particularly active week for near or actual landfalls, and that's always good news. But of course, that can change.
John?
Yes.
Yeah, so thanks for going over the tropics. I know this is your favorite place of the world to look at. The disturbance near the Bahamas is kind of interesting. It's an area of low pressure that's developed, and it's interesting that some of the computer models, the NAM as an example, intensify it to a 996 low in the central Gulf of Mexico, whereas the EF from last night and the GFS this morning don't really do too much with it. But this string of disturbances, particularly the ones in the central Atlantic and just off the African coast, are really interesting. If you look at satellite imagery over the continent of Africa, in the sub-Saharan part of the Africa, I guess in the Sahel, there's a whole string of disturbances that are moving off the across the continent. And in the Sudan, they were experiencing, this is in eastern Africa, experiencing some significant flooding. And I think there might be an interesting relationship between the flooding that's occurring there, this high frequency of waves that's moving across central and western Africa. Just interesting links between all of these phenomena that you don't think eastern Africa as being, it's viewed in some circles as perhaps a seed area for some of these initial convective complexes that become easterly waves. But that are just by the African coast, the yellow X and the deep red X are expected to become storms, perhaps, or likely to become storms in the next few days. So
they got high probabilities.
One of them could actually become one that threatens the U.S. down the road.
Yeah. So, and in fact, I think tomorrow, the 12th of September, is actually the calendric peak of the tropical Atlantic Basin hurricane season. So we're just about right on the maximum of number of storms in the Atlantic Basin on the 12th of September is higher than any other day if you add them all up or something like that. So we're right at the peak of the hurricane season, and we're already looking at a potential Hurricane Renee and an almost certain Hurricane Paulette. So we're well into the alphabet at the peak of the season. And now it looks like, as you're pointing out, it's not going to become, at least not immediately, it's not going to become relatively inactive. It's going to be just the opposite. So what a season.
And we may be with the Greek alphabet, Greek storms by the time we get to next week.
Unbelievable. Yeah, unbelievable. That's
Okay, there was a comment in the chat. Kalen mentioned that the NAM model is not coupled with the ocean, so it's probably not good to be used for predicting tropical cyclone intensities because it tends to over-strengthen them.
Mm-hmm.
So just throw that out there.
Yeah. Okay, so that's an overview of the past week. I want to now turn to the current weather if there are no other comments or questions or requested diversions. Okay. I'll start with just the current 500 millibars map for 12Z this morning. So I didn't highlight it, but the storm that we had hoped to talk about in our discussion in class last Thursday, 452, 751, is still evident on this map. It's now well off the domain of this, but the trailing baroclinic zone is part of that whole disturbance that roared through here on Saturday and Sunday of last week. Sort of a canonical, pretty decent intensity cyclone. In fact, it was pretty high intensity cyclone to the north of us, and we got a decent hit by it. But it's hung together for a long time. It's well now east of Greenland, as you can see, and the baroclinic zone trailing to the south. And as I showed earlier, we had that rapid ridge development on the west coast that led to the cutoff. And you can see now the separation between the position that this cutoff disturbance used to occupy in the broad westerlies, which is right here where it cut itself off from. And that feature is raced off to the east where the cutoff is kind of sat still over the western part of the plains. And that has kept us with some conditions that are unsettled. And so there's no question we've stayed cloudy and drizzly all week. It's been one of those fall-like weeks, relatively early in the season for it. Broad confluence at 500 millibars, centered on an axis just to our north. So we're on the warm side of that confluence at 500 millibars. That will be something to keep an eye on for at other levels as well. And then broad cyclonic flow just to our west. So we're going to go from the frying pan to the griddle, or whatever they say. We'll go from a confluent forcing for ascent to a cyclonic PVA type for ascent as we go from Friday into Saturday. So no cessation in the unsettledness of the weather, just different mechanisms that are going to drive it, it looks like to me. So let's go a little lower, the often neglected 700 millibar level, and at which level you can see clear evidence of the cutoff, and it's a cold core disturbance. The coldest temperatures are right in the middle of it, not surprisingly. And then downstream ridginess, so there's broad upper divergence over South Dakota, and then one can see confluent flow, not quite as dramatically confluent as it was at 500 millibars, but we still are on the right side, the warm side of that confluent flow to maintain ascent and cloudiness. And we'll go one step further to 850. And then it gets a little bit harder to really say anything about the confluence, and a little bit harder to say anything about the cutoff, but one gets more of a lee side trophy look to this, although the thermal structure doesn't quite characterize it as a lee side trough. So this one is a kind of a mix of what's residual from the upper cutoff and maybe some tendency for a lee side feature out to the east. So, but broad southerly flow, weak but broad, and then an anticyclonic type circulation over us at 850 millibars. I should have done 300 first. I'll do that now. And here it is. Maybe I didn't do it because all the action is off to our north and east, except for the cutoff with a little stubby and weak jet streak. This is like 85 knots or something, although the along flow speed change is significant from North Platte to places in northern South Dakota. So there's decent upper level divergence occurring here, both for the along flow speed change and curvature part of the flow. So we don't have a particularly potent dynamical situation for us. That's why it isn't raining heavily right now. We had better confluence earlier in the week, but it's still confluent, and the consequence of that is it's hard to clear out. There's no particular forcing for subsidence and clearing out of the skies. So it's kind of a hung in like that, rather nastily, I guess, in a way. Let's take a look at the satellite movie. I think I've got that. Where do I have that all saved? I guess I'm going to do it on this page as well. There's no reason not to. Okay, so let's take a look at the current satellite, and we'll look at the continental United States in the visible. Here we go. So we noted the cutoff disturbances all over the Intermountain West, sort of Colorado, and it's got an axisymmetric distribution of cloudiness. I think partly because on the eastern side, it's not just the cyclonic flow that's producing the ascent and cloud production aloft, but also the confluent flow into that jet structure that occupies the eastern part of Canada. So there's a broader region, an asymmetrically broader region of cloudiness to the east than there is to the west on this disturbance. And so one this flow going straight northward, and then a bifurcation about at close to Lincoln, Michael's hometown, and then some of it heads towards us in the southern part of Wisconsin anticyclonically, and then some heads cyclonically into the Dakotas. That'll be reflected in the radar as well. Here's one of those disturbances, the one that I think had the higher probability of formation into tropical storm over the Bahamas. I think it was the red X. Then the yellow X is a collection of thunderstorms just south of New Orleans or the panhandle of Florida. Here is Paulette, and we don't have enough range to see Renee. She'd be back over about here where my cursor is. So Paulette is forecasted to become a hurricane quite soon in the weekend, and there's Bermuda. Where is it exactly? I guess right here. Here's Bermuda, and Paulette appears to be making an end run for Bermuda right now, so we'll see about that. Okay, and you can see this doesn't look like a normal visible black and white satellite image. I think you have to agree. Everything's white where there's clouds, and everything's really dark where there's either inland seas or land, except over the western Pacific Ocean, west coast Pacific Ocean, where it looks gray. And that's because it is gray. It's smoke. And the smoke makes it all the way down to northern Mexico from these storms, and then all the way out, as we said, three widths of the state of Oregon out to sea, about 1,000 miles or more. So really incredible smoke plume over this whole region of North America from the catastrophe that's occurring there right now. Let's take a look at the West Coast satellite image. We'll do the infrared because the time of day is probably better for looking at that. And here you can see earlier this week, this ridginess that we mentioned in the discussion of the 500 and 300 millibar flow evolutions this week was more obvious. But even now, one can still see anticyclonic motion of these these water vapor elements in the northern coast of British Columbia. And embedded beneath that, to the south of it, is a cutoff upper cyclone. I think we saw that actually, didn't make any mention of it on those upper level charts. And the state of Hawaii lurks back, trying to find it on my screen. It's about right here, I think. Yeah, here is Hawaii. And so there's another cutoff disturbance, or cyclonic disturbance, I should say, at about the date line that is probably the first feature upstream of what's going on in the whole Eastern Pacific. Okay, so that's interesting. And then we should take a look at the national radar depiction as well. We'll do next. And so here you can see elements of the cutoff low and its influence on the weather in the central United States. So first, one can see the straight northward flow from central Texas into southern Iowa, and then this little bit of a blossoming of a floret of heavier precipitation raging across the eastern part of Iowa, and that has its eyes on southern Wisconsin. So I think within the next hour, maybe 2 hours, we're going to see some steady showers move in, and that's from this feature that's currently in Dubuque and just making its way across the border into far southwestern Wisconsin. And then here's the bifurcation I mentioned in southern Nebraska, where some of the precipitation elements start heading up to the north and west in South Dakota and along the Missouri River there in the Iowa-Nebraska border. And then back on the western side of the cutoff itself, which is located in western Nebraska, one sees some precipitation over parts of Wyoming and far northern Colorado. And then widespread, look at how beautiful these small-scale precipitation elements are coming in onshore from like a sea breeze that might be a little bit more organized than just that, because it goes all the way from Cape Hatteras just about to northern Florida. But nonetheless, beautiful tropical thunderstorm elements that pop up in the daytime heating. And then the feature associated with the area of concern from the National Hurricane Center looks obviously better organized than any of those. So that's interesting. And then is the western periphery of the one that has the higher probability of forming into a tropical storm. And on the Pacific West Coast, there's no precipitation, abundant cloud condensation nuclei from all the fires, but not enough to actually nucleate anything and turn it into precipitation. So widespread, clear, apparently, from the radar, but one has to look at more than one source. It's not clear there. Okay, let's take a look at the surface map. And here's the big surface map over the continental United States and Canada right now. So first go to New England, where the temperatures are moderate. Pretty nice day in September. Wind off the ocean at Boston, low dew point, so it's probably going to be one of those days we have. It's cloudy, but I bet you those clouds are scalloped on the underside, so it kind of looks like one of those picturesque New England days. The further inland you go, like northern Connecticut, you find the sky is not cloudy. Same is true at Albany, it's clear. Cloudy here is related, I think, to the broad cloud swath that we saw tied to the jet that's on the U.S.-Canadian border in the eastern part of the country. Dew points are high down in the Carolinas, where we see we saw all those thunderstorms coming on shore as the first latitude at which we saw them. Look at the 79 dew point at Cape Hatteras, miserable. 77 at Wilmington, 73 at Wilmington, 77 at, I forget the name of the city there. And then 77 dew point at Charleston, that's miserable. 77 at Jacksonville, 79 further down the coast. So miserably high dew points across all of the southeastern United States. There's a huge number of 70 plus. I don't see an 80. It might be a little too late in the season for that, even at this point in these locations. And then 70 dew points continue across southern Louisiana and eastern Texas. So really 71 even at 70 at St. Louis, 71 at Little Rock. So you got to get all the way to St. Louis before you find your last 70-degree dew point. Some of these showers that show up on the radar are pretty heavy. This one right here at is that Davenport? I can't remember what city that is. Ames, maybe. Heavy rain at Ames, 55 over 55, and cool rain for them. And then light rain all the way to the border at Rockford, and it's over here in the central part of Iowa. So it's only a matter of time and a short amount of time before it's raining at Madison. There won't be much evaporation as the first drops fall because the dew point depression is only 5. So it's going to moisten up pretty quickly. In fact, rain can hit the ground at Rockford with a dew point depression of 4. So as soon as it gets to Madison, it'll start raining. And then moistening the column will intensify the rain is likely the case. Here's some of that precipitation over the Dakotas. It's light. And then it's a little heavier, as we said, over Iowa. And then light precipitation trailing along what probably is a weak cold front. Some of it is far south, as like Parsons, Kansas, and then other places to the north and east. And then in the Pacific Northwest, where the fire is raging, the winds are mostly mixed and they're light everywhere in the state of Washington. Some of the fires are emanating from the southeastern part of the state. There's no observation there. Winds are pretty light. Light along the Oregon coast, a little bit offshore. There is a slight bias to an offshore wind in some of those locations. You don't often see this, but there's reported smoke observations. So there's the little smokestack symbol. You don't see that too often, but here you should see it everywhere. Here's another one in Sacramento, smoke. So they're all over the place. And again, weak winds everywhere over the state of California. Chris, maybe you can comment on whether or not good or bad for the fires. I would guess it's good to limit the spread, but it's probably not good for other reasons. I don't know. And there's
it's bad for the smoke. It's bad for the air quality because then the smoke doesn't go anywhere. But it's
okay.
The fire activity. And this actually is an interesting case because the smoke has been so thick that there's actually been a little bit of a reduction on the fire intensity because there's just not enough heating getting through to kind of mix the air mass and to allow those plumes to develop. So it's been kind of almost a self-limiting reaction, kind of interesting to watch.
Wow, that is interesting. I never even would have thought of that. That's really interesting. Yeah. So thanks for that comment. So that, the smoke with no wind, air quality goes down, but maybe the fire doesn't spread. So that's good, I guess. Okay. And then what did I want to show after the surface map? We looked at the upper charts. I think we'll head to the forecast next. And that I had planned for another page. And let's see if I can find that page on my screen. Yeah, because Pete done the GFS forecast model data set with, this is based on a Python program, right, Pete?
Yeah, it's using Python to basically recreate what WXP has been plotting for the last 20 some years. It's a work in progress, but it's getting there.
Yeah, and we've had a problem with, especially with the accumulated precipitation on the surface forecast maps that completely disappears with this. You'll see the center of our data plots are different, and I think in a positive way. And then you'll also see there's some really nice new PV maps that are made from the GFS data. So I'll show you just a few of those in the context of the forecast. Broadly speaking, it looks like it's going to be a rainy Saturday, a slightly better Sunday, and then after that, a whole week of gorgeous weather, it looks like, with intermittent clouds, a couple of days in the middle of there, but no precipitation. So we're going to have a really nice fall-like week, maybe a little bit warmer than fall-like, but not brutally warm, starting on Sunday and Monday. But Saturday is going to be a bit rainy. So let's start by looking at, this is from the 6Z run, by the way. I don't think the 12Z is ready now. I'll give it a try. Let's just see. And I can do one test. Oh, wait a minute. What happened there? Oh, no. Pete, did I just blow away your other maps? Oh, man. What did I do? Hold on a second.
You want me to post the link in the chat?
Yeah, could you do that? Because well, will I see it because I'm sharing my screen? I guess I can.
Yeah, hold on.
I had it all set up too, Pete.
That's okay. There may actually be a link to it on the Weather Watch links page, but they're out through 117 hours right now.
If you put this on the chat, the link.
Yep, I had to.
See it. Wow.
There you go.
Oh, okay, there it is. Okay.
Should be able to just click on it and it should pull it up too.
Oh yeah, I didn't want to run the risk of blotting myself off the. I guess it does it anyway.
Try just clicking on the link in there.
Well,
I think you just rejoined as a new user.
yeah, I did. What a pain. Now I'm going to hear myself talking too.
Yeah, I put it in there again. If you just click on that link, it should just pull it up in a web browser.
Okay. Do I got to log out of my?
I don't know what you did.
I'm on here twice. So let's get me off.
One of them, you're not going to be a presenter too. I wonder if I can kick your other one off. I'm going to kick your second one off, John, okay?
Good enough.
So you should still be there in your first one. Except I'm just seeing a blank page.
John, are you there?
I wonder if the second one took over the mic and the camera and we lost his first one.
Oh.
He's reconnecting on the first one. That should do it. I'll make him a moderator again. Oh, he still is.
I'm back, right?
You're back. Yeah, that was weird. So now
Okay.
I'm going to put the link in the chat again, and if you just click on that link, it should pop it up in a window.
Okay. Okay. Thanks, Pete.
But you'll have to share your screen again.
What? Okay. What if I
This
don't
is
want
why
it?
we're testing this today, right?
Yeah, that's right.
Wow.
Well, it'll still happen anyway. It won't. It's not that like it won't happen.
Right.
Just because we did it.
Yep.
All
Okay.
right, so this is okay. Let's see.
Yep. There you go.
Yeah, PV maps. Okay, great. Thanks, Pete. So this
Yep.
is the 12Z run. Great. I didn't get to look at that, so this is nice. So let's start with 500 millibar map, and we'll get the forecast for right now. So this is valid at noontime, right about where we are now. Here's our upper level cutoff, and it's just to our, it's almost directly to our west. And you can see a broad trough is part of the whole broad structure. And then strong westerlies across the Canadian southern part of Canada, except for this trio of cutoffs. I mean, two of them are honestly cut off, and the third one, well up to sea, is almost cut off. So this is a really unusual looking map, if you ask me. It's literally like a necklace and then a string of cutoffs to the south of it. And then here's Paulette. Here's disturbance that's about to expand off the issue where we are at 500 miles. Okay, so at 850 at the same time, which is just about now, you can see evidence of the presence of the cutoff is reflected in cold temperatures at 850 millibars, but it's not as nicely structured as the cutoff is at upper tropospheric levels. And we are in a region of little or no temperature advection at this low level. The wind vectors you can see are on this map, and they're bigger for the longer winds and so on. So you can see them, and they're white. So there's only weak temperature advection, but there is a decent baroclinic zone trailing from the original baroclinic zone that we were talking about last Friday with the storm that's now well off the coast of Greenland. That trails all the way back to the Great Lakes, becomes relatively diffuse, but one could argue that it's there even in Kansas and Oklahoma. So that's a pretty lengthy baroclinic zone and long-lived. And there's Paulette at 850. And at sea level, here's the precipitation that we saw. Look at this forecast. It's so fantastic. It's only 6 hours into the future, but there's what we saw on the radar going back to Texas. Here's the bifurcation in southern Nebraska, the piece going into the Dakotas, and the floret, the little bit heavier precipitation there over the nose of Iowa. Just right on target. Here's precipitation. If you watched any of the U.S. Open last night, they had a period of really heavy rain during one of the semifinal matches, and that was tied to this frontal passage through New York City. There's Paulette. My guess is Paulette is almost guaranteed to not make landfall in the eastern U.S. because this feature is just in the way. It's just the wrong phasing. So we'll see if that turns out to be true in the forecast. And then the strongest thickness gradient. Look at how sharply defined these lines are in this new way of doing these maps. I think it's quite nice. You can really see the nice thickness gradient in southern Canada. So that's where fall is. It's in southern and central Canada. It's not quite over, well, a little bit over us, but not quite over the continent. So let's move forward to 12 hours into the forecast. That'll get us to midnight tonight. The cutoff's hardly moved. Maybe it's consolidated a little bit. Looks a little bit more like what you draw if you were drawing an upper level trough on a blackboard in a class. It's really perfectly strict. And downstream of the trough axis, which runs through central Nebraska and western Kansas, there should be, and then there's a little ridginess over Lake Superior. Is really going to be nice upper divergence here by midnight tonight. So we're certainly going to be under upward vertical motion, and it'll be raining by the time we get there. I'm almost sure to see that in the forecast. There's Paulette. And then the two cutoffs that are at the same latitude but separated by a precisely similar distance in longitude. Just fascinating looking structure. Let's go to 850 at this time. That was 18 hours. Paulette, and evidence of the cutoffs. Here's the one over us, and here's the one over the Pacific, and not quite a cutoff further to the west. We'd already made that comment. Temperature hasn't changed very much for us, although the winds now are more strident out of the south and southwest, and there's warm air advection characteristic of the approach of an upper trough, and that warm advection is yet another mechanism by which encouragement for air to rise might be made. And let's go to the surface forecast. At this time, yeah, by this time the rain has clearly moved into the region. This looks like the thing that's currently in Iowa now, and died a little bit in intensity, but it's certainly beginning. It's already been raining here by midnight Saturday. I want to show you the 700 millibar maps because they're really cool. Pete's made a nice amendment to these. I think I might have said, Pete, I might prefer having a white background, but aside from that, the vertical motions that are the upward vertical motions are in the warm colors, and the downward vertical motions are in the darker blue colors. And you really sometimes see the distinction between these couplets of vertical motion don't look frontal at all. This one out here really does, doesn't it? I mean, there's warm air, there's air rising in the red, and then right alongside of it, there's air sinking. The same is true along this, we know is a cold front. And so you get this really nice couplet of vertical motions along this synoptic scale length, which you could easily see as part of a frontal structure. I'd say in response, reflecting that reality, the vertical motions associated with our cutoff don't seem to have much frontal structure to them at a first glance. And we'll see that tends to be true throughout the whole evolution. So these are nice maps. I'll highlight a couple of new things too that Pete's added here. And one of them is, we'll do it at the same temperature. So the 2 PVU surface, something's wrong going on there. There it is. The 2 PVU surface with potential temperature on top of it. So here you've got a really high potential temperature at 2 PVU, which means the 2 PVU surface is quite high in the atmosphere, whereas near the cutoff, it's pretty low. It's about 317 millibars when you hit 2 PVU. Here's exactly the same value, 317 at the next cutoff upstream, and then 326 is close to the next cutoff. If you go up to the pole, though, you get a really low tropopause. Let's see, am I thinking about that right? Yeah, the pressure here does that say 284? Yeah, 284. So that's
this is actually
this is theta. Sorry, 284 theta. Yeah, so right, 284 theta. So it's a really low tropopause up near the North Pole. Let me show you the corresponding pressure map on the same surface. So here things are a little bit different. Where you had a warm potential temperature, you're going to have a really low pressure because you have to go to 100 millibars before you find 400 Kelvin. On the other hand, to find 307 Kelvin, you can find that at 405 millibars, 403, or 415. To find 284, you got to go all the way down to 508 millibars. So you got to be really low in the atmosphere at high latitude to get that. So these maps are really quite nice. What you can see illustrated, broadly speaking, for our weather into the near future is you see a low tropopause and a high tropopause, which means there's a jet feature in between the two. And the jet feature is of what's organizing the precipitation. That's why it looks a little bit linear. It's not particularly frontogenetic. That's why there's blobs of ascent and descent, not lines of them with this feature. But nonetheless, they seem related to the jet. So this is a really nice map. There'll be times when we have really deep, intense developments where either one of these, probably both, will look really, really nice as pieces of analysis for a case that you might want to put together. So that's a really nice new addition. Yes, Michael.
Yeah, so if we could go to the theta map for a moment, please.
Yeah. And for anybody who's in the audience who doesn't know, Michael's the expert on these maps because he and John Nielsen Gammon wrote a seminal paper in 1998 that's been referenced thousands of times. So go ahead, Michael.
Yeah, I was going to point out that near, I guess that's Paulette in the Atlantic, you can see that red area there, the high potential temperature there, and that's characteristic of the outflow from the deep convection in the tropical cyclone. So it produces a plume of air that it emanates from the tropical cyclone. You can see another plume that's to its northwest. That's right in that area right there, and that's evidence of latent heat release and convection ahead of that front. And also these very strong temperature gradients along the surface of constant potential vorticity also acts as another indicator of an upper front. So you can actually identify frontal type structures on the dynamical tropopause.
Yeah.
So it's kind of a neat map to see the influence of deep convection and latent heating on the tropopause. And there's lots of dynamical structures that emanate from these maps, and we'll see a lot of that. These are nice maps that Pete's created.
Yeah, they're great. And one of the things that I, at a glance, I always say to myself, well, look, and here, I know this is the tropics. This is the northern coast of South America. This is, 15 degrees north in the Pacific. And these are the potential temperatures that characterize the tropopause in the tropics. Well, they happen to also be the potential temperatures that characterize the tropopause right over us. That's why you can sometimes get a tropical feel here. And then here, it's the outflow from a tropical cyclone, a local export of tropical tropopause. So it's really interesting how you can start to think about these weather systems that way. Okay, so this is really neat, this stuff that Pete's put together on this new page. And I think Pete's welcoming comments, especially good ones. No, I mean, he's welcoming comments on anything you would like to see changed on these things. And then soon enough, they'll go live because they're really quite good. So let's jump.
Can I point something out before you go on?
Yeah.
with those same maps that in those places where
you want the potential temperature map, Rick?
Yeah, you can put that up there.
Okay.
In these areas where you see the low potential vorticity, the tropical effects, those areas also, because they have low potential vorticity, they have low inertial stability. And because of that, tropical characteristics such as the low temperature gradient approximation, where everything smooths out in the tropics and you can't get very large pressure systems, pressure, low pressure, except for maybe a tropical cyclone near the surface. Otherwise, the pressure field, the temperature field is all kind of flattened out in the tropics. And that's also true inside these plumes of tropical air. And so these places where you see the low potential vorticity, not only does it look like the tropics up there, but it has tropical characteristics in terms of rotation. So it's basically the same. When you're in there, it's basically the same. I mean, if you're in that plume with that low potential vorticity, it's basically identical to being in the tropics where tropical type weather occurs as opposed to extratropical weather. So I think that's another very interesting aspect of it. Also, what's interesting is the contrast that occurs, such as up in North America right now, where you see very extratropical air right next to the tropical air.
Yeah, right in here.
Yeah, across that. So that contrast there is apparently quite important because the tropical air not having the inertial stability characteristics of the extratropical air is able to freely fill low pressure areas and evacuate high pressure areas. In other words, you can just flow can move without turning to the right very much.
Yeah.
And because the Coriolis effect is countered by low relative vorticity in those areas. So basically the way the atmosphere responds when you have a combination of the two next to each other was very different than if you just had an area of extratropical air with relatively high inertial frequency across the whole thing. And I think this can lead to the development of extratropical systems, accelerated development of extratropical systems as a result.
Yeah.
So,
one of the things that when you're talking about this, why I have an echo? I don't understand. Is that if you can project some extratropical forcing on top of this air column, which has tropical characteristics, at least at this elevation, you're going to get a lot more response to that forcing in this place than you will if you do it over here. So that can contribute to exactly what you're talking about, the rapid intensification of some of these responses.
Yeah, well, you look at what causes low pressure at the surface, and it's divergence in a column, right? I mean, you get when the cold air is sinking and pulling air from the warm column, the warm column has divergence aloft, and that causes the surface pressure to low. But the divergence is normally tempered, let's say slowed down by the fact that the air is turning to the right because of rotation, and the inertial stability allows it to only diverge so much before it reaches the Rossby radius of deformation and it's rotating or turning anticyclonically.
Yeah, it can't run away anymore.
In this case, where you have very low potential vorticity, it can just divert, like in the tropics. You can just evacuate the air. You can pull it right out, and it doesn't really have to turn very much because the potential vorticity is so low, and that allows you to just draw air right out of that column and lower the surface pressure extremely rapidly.
Yeah, because it can run away and hide.
Yeah.
Yeah. So that's really interesting.
Here's an interesting thought, because I hadn't thought about this with these maps. But since we're looking at the surface of constant potential vorticity, it'd be interesting if we could formulate an expression for the inertial frequency in isotelic coordinates, in constant PV coordinates, and it would have to be related somehow to, I think, the gradient of potential temperature along the dynamical tropopause along this surface. So there might be an interesting way to formulate inertial stability on a surface of constant potential vorticity in terms of theta.
Yeah, that's true, and maybe some diagnostics for vertical motions too on constant PV surfaces. Because if you could overlay all of these things and you knew we were talking about the same surface, you'd really have something kind of new to look at in terms of where are the hot spots and how are they going to respond.
Yep.
Yeah, that's really interesting.
That's kind of what I've done to a certain extent on those inertial stability maps around isentropic surfaces. And, that's, when I'm looking at the spokification and all those sorts of things, that's kind of what that is.
Mm-hmm.
So.
Yeah, very interesting. Okay, let's just quickly go through a couple more rounds in a temporal sequence. I think we'll I'm allowed to. What's my connection? Okay, so this is going to get us to noontime tomorrow, by which time the cutoff is gradually encroaching again on the westerlies that are into southern Canada and kind of zipping itself up a little bit, but it's encroached also on our own state. And so you get we're kind of smack in the middle of probably the strong forcing from the proximity of this upper cutoff. And notice that the string of cutoffs really remains pretty much constant. They're all progressing somewhat to the east, just as they had, and here's Paulette. So at 8:50, we're going to see some interesting things by this time. This again is for noontime tomorrow. So the coldest air aloft is just to our west, and we're no longer really experiencing any temperature advection at all. There's a decent looking cyclone developing along that thickness gradient baroclinic zone that I'd mentioned before in southern Canada. So that's a nice looking storm. In fact, some of the first snows of the year are going to fall in some of the provinces in Alberta and Saskatchewan, just to the west of the shores of Hudson Bay. So that's interesting. You put snow on the ground there early, maybe that just makes it easier to build cold air there. And here's some cold air further north where it's probably already got snow cover. Not much ice here, though. It's been unusually warm in this portion north of the Bering Sea, most of this summer and fall. So I like to see snow falling there if that's what in fact is going to happen. So let's go to the surface forecast. Oh, sorry, I went to the same one. And there's some of that precipitation in a region where it's cold enough to snow. So it's the beginning of the snow season in parts of the prairie provinces. It's raining over us by noon tomorrow. It's been raining, I should say. And there's the 3-hour accumulated precipitation. It's on the order of 1/10 of an inch maybe or something like that. So a consistently wet but never heavily precipitating day. And there's Paulette. Here's the trailing cold front from the major storm in the to the east of Greenland, and so that's going to be insulation for Paulette. It probably won't make it past that boundary, but it might get fixed to that boundary, and some interesting things could happen as a consequence. And then let's go to maybe one more 12 hours, a couple more. Here's the cutoff sitting over us by midnight Saturday night. At the same time, we're getting kind of right into the heart of the cooler air. It's not quite as cold as it used to be associated with this 850 millibar feature tied to the cutoff. Cyclone over Hudson Bay is getting a little more intense, though. Really canonical cold and warm frontal structure associated with it. Quite nice. And then at sea level, it's a 996, 995 millibar low with a pretty nice cloud shield and precipitation shield out to its east. Not much happening back to the west in the cooler air. A little bit of snow probably in southern or central Saskatchewan. And it's raining still, now moved over to Michigan, still raining over us by about midnight Sunday. That might be the end of the rain for us for some period of time, though. Big anticyclone off the east coast, and the baroclinic zone from the old storm is kind of now getting itself embedded, oriented in an east-west orientation. And there's Claudette spinning around over Bermuda, probably having wrought some damage there over the weekend. And then let's go forward just at sea level pressure at 12 hours. There's Claudette. Our storm has moved out. It's gotten a little more intense in Canada. There's not much snow back in the cold air, and we're starting to finally see clearing by the time we get to midday Sunday. It'll be beautiful temperatures, actually, just exactly what you want around this time of year. This is now 7 a.m. on Monday, anticyclone sitting to our north, some cool advection to our east that had been occurring during the Sunday for us. So clearing skies. We might have a fairly chilly Monday morning, not cold, but chilly. And then there's the main storm that we saw develop just to our north on Saturday. It's gotten a little more intense. It's down to 988. And there's Claudette making slow progress to the west, of all things. And
yeah, that high is going to kind of trap it temporarily before it can head off to the northeast.
Yeah, that's really interesting. So it's going to be churning up waves. Good day to go to the beach in the Carolinas. Probably not terribly hot. Big waves. Could be fun. And then there's the anticyclone sliding, as they always do, to the south and east, mostly in this case to the east so far. And then we'll get the return southwesterly flow and warm us up. This is Monday night. As I said, the beginning of an absolutely beautiful week. Notice that the thickness contrast to the south is not great. So it's not really brutally warm to the south. It's making slow approach to the east coast. We'll see what happens in the next iteration. The cyclone center here is down to 974. So this is a very intense cyclone that began its life Saturday or Sunday just to our north and turns into a pretty intense disturbance. I think I'm going to go one more. That's to 96 hours. Yeah, this is okay. So we have a little bit of a warm ridge building in. I'm showing based on the thickness field at 1,500 millibars with southwesterly geostrophic flow. So it'll be a little bit of a warm advection maximum. At its end, there's a region of precipitation in southern Ontario. And here's the cyclone that started off to our north and east. It's made it over to the Labrador Sea. And here's the cold front. And there's Claudette attaching herself to the cold front. And it's worth it on your own time because it's just turned 1 o'clock to take a look at what happens with Claudette. We don't see any evidence in this domain yet of Rene, nor of anything else that's developed into a tropical type cyclone. Yeah, I think in the longer term future, Michael made a comment about it. Some of the waves off the African coast do show up at like 192 hours as new tropical disturbances. One of them maybe with the potential to make landfall in the southeast U.S. So it's going to be an interesting week to watch the tropical Atlantic. It's going to be a beautiful week for us as we clear out. And there's no resetting of really strong offshore flow in the western United States. And I think that's good for at least not spreading the fire anymore. It's still going to be difficult to contain it, I suppose, but I don't think there'll be any substantial wind aiding its spread in the early part of the coming week. And that's good news for people who are suffering out there. So
yeah, well, quick points,
that's
John.
the discussion for today. Any comments or questions, or if you want me to direct our attention to anyplace else, I'd be happy to do so.
Yeah, very quickly, John. There's the area of low pressure that's just southeast of New Orleans is that wave that was over the Bahamas. It's moved into the Gulf of Mexico. In this model run, it hasn't strengthened, but also notice that the low changing.
Am I still here?
Can you hear me?
You're still there, John.
Oh, okay. Okay.
Hello?
Yeah.
We're good.
Oh. Yeah, I was going to say that the cyclone that's just to the southeast of New Orleans is that wave, that disturbance we saw near the Bahamas. So it'll be interesting to watch how that develops. The Paulette off the east coast, it looks like it's going to stay out to sea, but I would just be careful. The progression of the anticyclone that was to its north, just how quickly it moves off, may control whether or not it makes a closer approach to the east coast. And you're right, the patterns changed out of the western United States, actually getting an onshore flow, and the GFS is actually depicting some precipitation there, so that might actually make it a bit pleasant for some of those areas, cooler and maybe higher dew points along the coast.
John, can I screen for a minute? I want to show something.
Yeah, sure. Let me get off the screen.
While you're taking the screen, I just want to remind everybody we'll be starting at 12 o'clock on Fridays because of the class, so it's 12 instead of 12:15. Also, I posted a link in the chat. If you get a chance, take a look at the Madison climate data that Ed Hopkins puts together. We had 3 days this week where we had record low high temperatures. Our high temperatures were actually below the normal minimum, which is kind of crazy. And also, one last thing, there was a discussion between Dan Vimont and Liz Maroon on Twitter about when the last time classes got canceled for a snow day. And Dan just posted, one of those may have been John Martin's doing. I remember showing up at the bus stop with nary a flake in the sky and ran into John. He said he had just told the chancellor to cancel classes for the first time in umpteen years due to potential snow. I looked up at the sky, not a flake at 5 p.m. and thought, that's the end of our department. That evening at the basketball game, the chancellor canceled classes, and then we got hit with massive issues due to wind and blowing snow. I shouldn't have doubted John. There you go.
Let me just thank you, Pete. That's very nice, but I'll make an amendment. you should doubt me when it comes to forecasting, except when snow is on the line. For some reason, I pay closer attention and I do a better job. I do. So anyway.
No wish casting involved, huh?
No, that's right.
Awesome. So you got to let go of your screen if Greg wants
Okay,
to
yeah.
share.
Okay, I'm off, Greg. Go right ahead.
Okay. You see that? Yeah,
Yep.
you see it.
It's a little small, but
Okay,
yeah.
these are the jet streams again. This is initiated, this is the GFS run, just showing jet streams 40 meters per second or greater in 3 dimensions. I wanted to point out, as usual, this is the polar night jet down here that's up in the stratosphere, but these subtropical jets are connecting with it. As remember last year I talked about the one in the northern hemisphere and how we connected and caused big time weather. Well, they're doing that in the southern hemisphere. They always do, but much more regularly. But in particular, I wanted to look at Paulette, which is right over here, and watch what it's going to do. I'll space through this, go forward in time, and now you can see this arching. This is a plume coming off of Paulette, I believe. And you can see that warm colors here. These are the low potential vorticity on the southern side of this tropical plume coming off of Paulette. And this is for Tuesday right now. And you can see it intensifying this, growing this subtropical jet here. And then we go forward in time, and then that subtropical jet is now entering into North Africa and Europe, moving over there. So what I'm wondering about is, as this comes into Europe over here, what's this going to do? Because we know that Mediterranean storms seem to be connected to Atlantic hurricanes. And so as this anomaly moves into the Mediterranean, we may have some very interesting weather toward the end of next week in the Mediterranean. In fact, I know from people in Israel that they have a general rule at the Weather Forecasting Office in Israel that you count 10 days after a hurricane in the Atlantic, and that's when you're going to get some kind of a big event in the Mediterranean, even in the East Mediterranean by Israel. So I just thought I'd point that out.
That's very interesting. Does it matter where the tropical disturbance in the Atlantic goes and what sort of path it takes, or is it pretty wide range?
Well, it's a wide range. Sometimes they actually affect Central Europe too. In fact, some of the ones I've looked at affect up by Scandinavia. They can produce a plume that goes all the way up, and then it creates some kind of a big anomaly in Scandinavia. But sometimes those anomalies up very far north work their way down to Southern Europe as well, as fronts and so on. But in this case, it looks like it's going right into the Mediterranean. So it could be different for every case. But the point is that the anomaly, the energy, the potential energy that's put up there in the UTLS has legs on it now, and it goes into the Mediterranean and can do things.
That's very cool.
Just thought I'd point it out.
Yeah, thank you, Greg. Appreciate that.
Sure. I'll give you a screen back.
And that's consistent with some of the stuff we saw on the new PV maps that Pete made. That plume we saw come, like Michael pointed out, that plume we saw coming out of Paulette at one of the forecast times, 18 hours into the forecast. It's exactly the kind of warm shading that you're seeing on your ice attack map.
That's right.
Yeah, that's really neat. Well, thank you, everybody. And Pete, thank you for the broadcast and for setting everything up. We'll be back next Friday. It will be officially part of 751 and 141. And 751 will be groups of 2 people from 751 will be presenting these discussions later in the term. We're going to let them marinate for a while so that they get a sense of how they're done. And then they'll be presenting those as a group of 2. So there'll be 4 such groups at some point during the term, and that'll be part of their assignment in 751 as we plan. So really exciting.
Nice. All right, thanks everybody. I will put the recording of this up on our YouTube channel if you want to check back on it later, and we'll see everybody next week. Hey,
Thanks,
John, hang on for just a second yet before you go.
Okay.
One recommendation every once in a while your feed would kind of freeze up for a second, and you'd be talking, and then all of a sudden it would kind of scatteredly come back through, and you'd catch up. I wonder if maybe you turning off your camera during the part where you're originating the presentation would help with that, because then you wouldn't have the bandwidth of your, lots of people saying thanks, we wouldn't have the outbound bandwidth of your video.
Yeah, okay, I'll do that next week. Okay.
Posted, yeah, there you go. It's nice to see the little postage stamp of you getting excited about what you're talking about, because you do get excited, and that's awesome. But I think let's try that and just see, because I had my video muted and Michael did too, and I don't think that impacts being able to share your screen.
Yeah, it doesn't.
Right.
Okay, I'll give that a try.
One suggestion: maybe have it on at the beginning when you're introducing, and then when you go to share your screen, turn it off first.
Okay.
And how that goes. But otherwise, great discussion. I'm really thankful that you came on and did that. Your discussions of the weather are far more intuitive and enlightening than me just going around and saying, well, it looks like it's sunny in the Northeast and humid in the Southeast and terrible day in Florida.
Thanks, Pete. I'm sorry I didn't get back to you on saying that.
No, that's fine. I'm glad you were here, and I thought that went as well as we expect this to work. So
yeah, I'm really happy. So I think it's great. I think we're going to be able to make this work. So fantastic.
Sounds good. Great. Okay. Thanks, John, and have a good weekend.
You too, Pete. We'll see you.
Stop recording now.
Bye-bye.
Bye-bye.